All the past paper questions. This will cover, of course, perpendicular lines, parallel lines, gradient equals tan theta, altitudes, medians, perpendicular bisectors, anything else you can think of. Let's go straight ahead into this. SQA Higher Maths 2015, paper 1, question 9. ABC are points such that AB is parallel to the line with equation y plus root 3x equals 0, and BC makes an angle of 150 degrees with the positive direction of the x-axis. Are they collinear? So you need to know what collinear means. They are all in a straight line. So if you work out if A to B are parallel and B to C are parallel, and when it says B is a point in common, they would be in a straight line because they're parallel or not. So let's just work on this. So the first part is to work out the gradient of AB. So for A to B, we have got y equals minus root 3x. So the gradient of that section is just minus root 3. For B to C, well, gradient equals tan theta because we've got the angle 150 degrees. So our gradient is equal to the tan of 150. Now, 150 is going to be an exact value. If you've got a cast diagram, we can see it's related to 180 minus 150. So if I work out the tan of 30 degrees is 1 over root 3. But 30 degrees is positive here and here. So that's 180 plus 30, which is 210. And that's 180 minus 30, which is 150. Here, tan is negative, so the tan of 150 is minus 1 over root 3. And then we can just make a little statement. Since the gradient of AB doesn't equal the gradient of BC, the points are not parallel. And so they're not collinear. Not parallel, so not collinear. Now, if they were equal, you would then say they are parallel, but since B is a common point, they're collinear. SQA National 5 Maths 2016, paper 1, question 11. Find the equation of a line passing through minus 2, 3, which is parallel to the line with equation y plus 4x equals 7. So parallel means same gradient. So I need the gradient and a point to work out an equation of a straight line. So let's work on the gradient first. So y equals minus 4x plus 7. So our gradient is minus 4 because it's parallel. Gradients are the same. Now we'll use y minus b equals mx minus 8. And there's our point A and B. So we've got y minus 3 minus 4x minus minus 2. Okay. And then we can just work that out. Y minus 3 is minus 4x. 4 times 2 is 8, so it's minus 8. So y equals minus 4x minus 8. Add 3 is minus 5. SQA Higher Maths 2017, paper 1, question 11. A and B are points, these here. AB is parallel to this line, find the value of A. So parallel means same gradient. So if we look at 3y minus 2x equals 4, that means that 3y equals 2x plus 4. So y is equal to 2/3 of x plus 4/3. Key point is our gradient is equal to 2/3 because it's parallel to this line. And then we've got our points here, but we know if we use a gradient form on that, we need to get an answer of 2/3. So y2 minus y1 over x2 minus x1. So I'm going to do a take away 2 on the top and 5 take away minus 7 on the bottom, but that equals 2/3. Save it, 3 times a minus 2 equals 2 times 12. So 3a minus 6 is equal to 24. Nice and simple to solve. We get 30 and a is 10 for our final mark. SQA Higher Maths 2019, paper 1, question 7 had this one. The line makes a 30 degrees angle with opposite direction of the x-axis. Find the equation of the line perpendicular to it, passing through 0, minus 4. So looking at the line L, the gradient is equal to the tan of 30. So the gradient of that is 1 over root 3 because it's an exact value. Now we can work out the gradient of our perpendicular. So the gradient of our perpendicular is equal to minus root 3 since m1 times m2 equals minus 1 because of perpendicular gradients. And then we can use our point. So I'll call that A and B. Y minus 4 equals minus root 3 x minus 0. Y plus 4 equals minus root 3x. Or y equals minus root 3x, take away 4 would be fine as well. And we're done there. SQA Higher Maths 2022, paper 1, question 1. Determine the equation of the line perpendicular to 5x plus 2y equals 7, passing through minus 1, 6. Perpendicular, which means the gradients multiply together to give minus 1. So for gradient of this line, we've got 2y equals minus 5x plus 7. So y is minus 5 over 2, x plus 7 over 2. The gradient of this line is minus 5 over 2. So the gradient of our perpendicular line is equal to 2/5, since m1 times m2 equals minus 1. 2/5 of minus 5 over 2 gives us 2 marks already. Then we can just do the equation of a straight line. Y minus b equals x minus a. Minus 1 is plus 1. So 5y minus 6 you might do is 2x plus 1. Expanding our brackets, we get 5y minus 30 is 2x plus 2. So I'll leave it with 5y is equal to 2x. 2 plus 30 is 32. And you can leave it in any form you want. Y equals mx plus c. And multiples of y equals a multiple of x plus a multiple of a number. Whatever you want, really. So 5y minus 2x equals 32. And you can just leave it like that, or in any other correct form for the equation of a straight line. SQA Higher Maths 2017, paper 2, question 1 had this one. It's your standard, you've got a triangle, the coordinates of B are 3, 0, C are 9, minus 2. So I'll just write these as we go. And the broken line is the perpendicular bisector of BC. Find the equation of a perpendicular bisector. So a perpendicular bisector cuts a line in half at right angles. So I can find the midpoint using the midpoint formula and then go from there. So for part A, I'll just call this point M. M is equal to 9 plus 3 over 2 and 0 minus 2 over 2. 12 divided by 2 is 6. Minus 2 divided by 2 is minus 1. So we get our middle point, our midpoint. We now need the gradient of BC. Then use perpendicular gradients. So the gradient of BC is equal to minus 2 take away 0 over 9 take away 3. That's minus 2 over 6, which is minus a third. So therefore, the gradient of our perpendicular is equal to 3. M1 times M2 equals minus 1. And we've got a mark there for getting a gradient of BC, then our perpendicular gradient, and then finally to get our equation of a straight line, using our midpoint, y minus b, mx minus a, y plus 1 is 3x minus 6, or y equals 3x minus 18, take away 1 is minus 19 for our final mark. B says the line makes an angle, the line AB makes an angle of 45 degrees with positive direction of the x-axis. Find the equation of AB. So we're going to find the gradient using tan theta, and then use the point A to find the equation of the straight line. That would be M equals tan of 45 degrees which equals 1, and our point. So the point we've got is point B, which is 3, 0. So our point is 3, 0. So y minus 0 equals 1x minus 3, or y equals x take away 3. And we've got 2 marks here. Part C. Find the coordinates of the point of intersection of AB and the perpendicular bisector BC. Simultaneous equations, in other words. So we've got 2 equations, 3x minus 19 and x minus 3. Y equals 3x minus 19, y equals x minus 3. Since they're both y equals, I can say that this side equals this side. So we get 3x minus 19 equals x minus 3. So 2x equals 19, take away 3 is 16. X is equal to 8. So we get 8 and then sub it in to get y. Well, we know that y equals x minus 3, which is 8 minus 3, which is 5. The coordinates of the point of intersection are 8, 5. And we're done there. SQA Higher Maths 2018, paper 1, question 8. The line has the equation y minus root 3x plus 5 equals 0. Determine the angle the line makes with the positive direction of the x-axis. Well, gradient equals tan theta if it's talking about angle and gradients. So let's get the gradient first. So y equals root 3x, take away 5, putting it in mx plus c form. Our gradient equals root 3, and gradient equals tan theta, which is equal to root 3. So theta is the inverse tan of root 3. The inverse tan of root 3 is 60 degrees, or pi over 3. And we're done there, it's an exact value. SQA Higher Maths 2019, paper 1, question 7. The line L makes a 30-degree angle with positive direction of x-axis. Find the equation of a line perpendicular passing through 0 minus 4. Gradient equals tan of 30, which is equal to root 3. 1 over root 3. So that means the gradient of our perpendicular is equal to minus root 3, since m1 times m2 equals minus 1. And then we can just use y minus b, y plus 4 then, equals minus root 3, x minus 0. So y equals minus root 3x minus 4, and we're done there. Question 5, a line makes an angle of pi over 3 radians with the y-axis and passes through minus 2, 0 as shown. Determine the equation of a line. Well, with the y-axis, that's not what gradient equals tan theta. It's the positive direction of the x-axis, so I'm going to have to get this one here. If you imagine I drew a little line here, these two angles would add up to 90. Well, pi over 3 is 60, so working in angles if you want, you would get 30 degrees. So our gradient is equal to the tan of 30, which is 1 over root 3. And then we've already got a point, so y minus b equals mx minus a. Y minus 0 is 1 over root 3, x plus 2 minus minus 2. So y equals 1 over root 3x and plus 2 over root 3. And we're done there. SQA Higher Maths 2015, paper 2, question 1. Quite a standard one this. We're given a triangle and we have to work out the altitude, the median and the point of intersection. So our points that were given in the question are minus 5 and 7, minus 1 and minus 5, and 13, 3. So altitude first, so it cuts the opposite side at right angles. So I need to use m1 times m2 equals minus 1. So for part A, the gradient of AB is equal to y2 minus y1 over x2 minus x1 minus minus. So that's minus 12 over 4, which is minus 3. Therefore, the gradient of the perpendicular is equal to a third, because m1 times m2 equals minus 1. And you've got 2 marks already for getting the gradient and then the perpendicular gradient. And then using y minus b equals mx minus a. Our point is 13, 3. So we've got y minus 3 is a third of x minus 13. So 3y minus 3 is x minus 13. 3y minus 9 is x minus 13. And we want to make it look like x minus 3y. So taking the 13 over to this side, that gives 4 equals x minus 3y, or x minus 3y equals 4. Just making it look like it's asking in the question. Part B says, find the equation of a median from B. So median means we need to cut AC in half and then use the gradient formula to find the gradient. So our midpoint, this is the average of the x's, minus 5 plus 13 over 2, and the average of the y's, 7 plus 3 over 2. 13 minus 5 is 8, divided by 2 is 4, and then 7 plus 3 is 5, 10 divided by 2 is 5. So there's our midpoint. So if I call our midpoint, let's call that M. Then the gradient between M and B. B is minus 1, 5. Minus 1, minus 5. So our gradient is equal to y2 minus y1 over x2 minus x1. So just call that x2, y2 and x1, y1. We get minus 5 over minus 1 minus 4 minus 10 over minus 5 is equal to 2. So we get a gradient of 2, and we've got 2 marks so far for our midpoint and our gradient, and then just find the equation. So y plus 5 equals 2x plus 1. So y plus 5 is 2x plus 2, or y equals 2x minus 3, 2 take away 5, and then there's our final mark. Okay, part C, find the point of intersection between the altitude and the median. So we've got 2 equations. We've got x minus 3y equals 4, and we've got the other one we've just worked out. So let's note these down. X minus 3y equals 4, and y equals 2x minus 3. Do this any way you want, but I'll just make them both look the same. So if I taking this one and putting it underneath, we've got y, we've got minus 2x plus y is equal to minus 3, and we've got 2 simultaneous equations we can solve. So times in this one by 2, we get 2x minus 6y equals 8, minus 2x plus y is minus 3, add because the signs are the same. Minus 6 plus 1 is minus 5. 8 plus minus 3 is minus 5. So minus 5y equals minus 5, or y is equal to 1. So minus 5y equals 5. So y equals minus 1. There's our y coordinate, and then subbing it in, so we've got x minus 3y equals 4. So x minus 3 times minus 1 equals 4. X plus 3 equals 4, so x equals 1. So the point of intersection is just 1 minus 1, and we're done there. SQA Higher Maths 2016, Paper 2, Question 1. Another triangle, this time with the state the coordinates of M, the midpoint of QR. So let's take a note of some of these points. We've got 0, minus 4, and R is 10, 6, and Q is minus 6, 2. And then find the equation of PM and median. So part 1, the midpoint of Q and R. So we've got 10 plus 0 over 2, and part 1 we've got minus 6 plus 10 over 2, and then we've got 2 plus 6 over 2. That's equal to 4 over 2, which is 2, 8 over 2, which is 4. Our midpoint is 2, 4. Part 2, find the equation of PM, the median through P. Okay, so the gradient of PM, we've got 4 minus minus 4, and we've got 2 minus 0. That's 8 over 2, which is 4. Now we can use y minus b equals mx minus a. P is 0 minus 4, so we've got y plus 4 is equal to 4x minus 0, or y equals 4x minus 4. And we're done there. Part B. Find the equation of the line L passing through M and perpendicular to PR. So we're looking for the line that is perpendicular to this one. So it's perpendicular to PR. So we need the gradient of PR. And we'll use perpendicular. So it's 6 minus 4. And 10 minus 0. That's 10 over 10, which is 1. Therefore, the gradient of the perpendicular is minus 1, because m1 times m2 equals minus 1. And then the point we're using, it passes through m. Well, we know m's 2, 4. So that's our a and our b. So we've got y minus 4 equals 1 minus 1x minus 2. Y minus 4 is minus x plus 2, or y equals minus x plus 6. And that gives us our second equation. Third question says, show the line L passes through the midpoint of PR. So we need to find the midpoint of PR and show that the line passes through it. So midpoint of PR, part C. Zero plus 10 and minus 4 plus 6. 0 plus 10 over 2, minus 4 plus 6 over 2. That's 5. That's 1. So we've got to 0.51, and we need to show that our line passes through that point. So we might as well just substitute the x part in and see what we get for the y part. So when x equals 5, we've got y equals minus x plus 6. So y equals minus 5 plus 6, which equals 1. And then when y equals 1, y equals minus x plus 6, 1 equals minus x plus 6. So minus 5 equals minus x, or x equals 5. So we've just shown that 1 and 5 both work, and therefore the line passes through the midpoint of PR. And we're done there. SQA Higher Maths 2017, Paper 1, Question 7. A, B, and C are vertices of a triangle. Find the equation of a median through C. So there's A, there's a B, there's a C out here somewhere. Really bad sketch, but it is a triangle. A median cuts the opposite side in half. So we made the midpoint, always call this M. M equals the midpoint of A and B, so we've got minus 3 plus 7 over 2, and we've got 5 plus 9 over 2. 7 minus 3 is 4, divided by 2 is 2, 5 plus 9 is 14, divided by 2 is 7, so we get our midpoint of 2, 7. Now, our midpoint is 2, 7, so our gradient of M to C, well, C, we've got 11 minus 7 on top, over 2 minus 2 on the bottom. 11 minus 7 is 4, over 0. Oh, wait a minute, we're dividing by 0, we can't do that. Therefore, vertical line. If you get an undefined gradient, it is a vertical line. Gradient is undefined. The equation of a vertical line is just x equals. So the equation is x equals, and you should be able to see this, the x part is 2 here, It's also 2 here. So if you ever get that the same x, then the equation is x equals. If it's the same y, the equation would be horizontal, it would be y equals x equals 2. And we're done. SQA Higher Maths 2017, Paper 2, Question 1. Again, we've got a triangle showing. It says the coordinates of B are 3, 0, and C is 9, minus 2. And the broken line is a perpendicular bisector of BC. Find the equation of a perpendicular bisector. So for an equation, we need a point and a gradient. So we're going to need to find the midpoint. Let's just call that M, and then we can find the gradient. So for part A, the midpoint, 3 plus 9 over 2, 0 minus 2 over 2. That is equal to 6 minus 1 for our midpoint. So the gradient of BC is minus 2 take away 0 over 9 take away 3 minus 2 over 6, which is minus a third. And then, since we know of perpendicular, the gradient of our perpendicular is equal to 3 because m1 times m2 is minus 1. So there's our key thing there, and we've also got our point. So y minus b equals mx minus a. It was minus 1, so it became plus 1. So y plus 1 is 3x minus 18. So y is 3x minus 19. And we've got our mark there. Part B. The line makes AB makes an angle of 45 degrees with the positive direction of the x-axis. Find AB. Gradient equals tan theta. Gradient equals the tan of 45 degrees, which is equal to 1. And then we have to find the equation of AB. So pick a point. Well, we're going to pick point B as 3, 0. So our point is 3, 0. Y minus 0 is 1x minus 3. So y equals x minus 3. And we're done there. Part C, find the coordinates of the point of intersections of AB and the perpendicular bisector BC. Solve simultaneous equations. So we've got two equations, y equals 3x minus 19 and y equals x minus 3. So we can say that 3x minus 19 equals x minus 3. So 2x equals 19 take away 3 is 16, so x is equal to 8. Subbing that in to y equals x minus 3, we get 8 minus 3, which is 5. The point of intersection is 8, 5, and we're done there. SQA Higher Maths 2018, Paper 1, Question 1. PQR is a triangle with vertices P minus 2, 4, R, Q, 4, 0, and R, 3, 6. Find the equation of a median through R. A median cuts the opposite line in half. It even shows you that, so let's call that M. To work out M, we can do minus 2 plus 4 divided by 2, and 4 plus 0 divided by 2. That gives a 4 take away 2 is 2, divided by 2 is 1, and 4 divided by 2 is 2. So we've got our midpoint, so we can now do the gradient between M and R, because it's not perpendicular, and then use y minus b equals mx minus a. So the gradient between M and R, we can do 6 take away 2, y2 minus y1, over 3 take away 1, x2 minus x1. That gives us 4 on the top and 2 on the bottom, which is 2. And now just use y minus b is mx minus a. So I've got y minus 2 is 2x minus 1. Y minus 2 is 2x minus 2. So y equals 2x minus 2 plus 2 is 0. SQA Higher Maths 2018, Paper 2, Question 5. PQR is triangle PQ and R with the numbers on it, 3, 4, 9, minus 2. Part A, find the equation of L1, the perpendicular bisector of PQ. So if it's perpendicular bisector, it cuts it in half at right angles. So if we call this point M, our midpoint, is equal to 9 plus 3 divided by 2 and minus 2 plus 4 divided by 2. That equals 12 divided by 2 is 6. 4 take away 2 is 2, divided by 2 is 1. So our midpoint is 6, 1. The gradient between P and Q, minus 2 take away 4 on the top, and 9 take away 3 in the bottom. That is minus 6 over 6, which is minus 1. So then continuing to work on this one, the gradient of our perpendicular is now equal to 1 because m1 times m2 equals minus 1. And the point we're using is 6, 1. So y minus 6 is 1. So y minus 1 is 1 times x minus 6, or y equals x minus 6 plus 1 is minus 5. The equation L2, the perpendicular bisector PR is 3y plus x is 25. Find coordinates of the point of intersection between L1 and L2. So 3y plus x equals 25 is one equation, and y equals x minus 5 is the other one. So making this one look the same, we would have y minus x equals minus 5, because the y is an x on both sides. We can add them together to get 4y equals 25 minus 5 is 20, so y equals 5. And since we know that y equals x minus 5, 5 equals x minus 5, so x equals 10. Our point is 10, 5, x and y. So we know the centre of our circle is 10, 5. And for the equation of a circle, you need two things. You need the centre and you need how big the radius is. The distance formula between the centre and one of the points, let's just use C and Q. So the distance I'm going to try and work out is this distance here, because that will be my radius. So my radius is going to equal the square root of 10 minus 9 squared plus 5 minus 2 squared. x2 minus x1 squared plus y2 minus y1 squared. And that equals the square root of 10 minus 9 is 1 squared. 5 plus 2 is 7, so it's plus 7 squared. 1 squared is 1, 7 7 is 49, that is 50. And now, once you do circles, you'll see this, but very briefly, the equation of a circle, and you're given it at the start of the exam paper, is x minus a squared plus y minus b squared equals r squared, where a and b is the centre of your circle. So the equation of this circle is simply x minus 10 all squared plus y minus 5 all squared, and the radius squared is just 50. And we're done there for our final mark. SQA Higher Maths 2019 Paper 2 Question 1. We had this picture and A was minus 5 minus 12, B is 11 minus 8, and C is minus 3 minus 3, 6. And fairly standard, find the equation of median, then the altitude, then the point of intersection. So the median of BD, so just working out exactly what it's asking me. This is the median they're asking us, so we're cutting this one in half. So I need the midpoint of A to C. So part A, I'll call D as the midpoint of A to C. So we've got minus 5 minus 3 divided by 2, and we've got minus 12 plus 6 divided by 2. That's minus 8 over 2 is minus 4, and that's 6 over 2, which is 3. So we get our midpoint of minus 4, 3. So that is minus 8 over 2, which is minus 4, and minus 6 over 2, which is minus 3. So now we can do our gradient between D and B, because we don't know anything about it. It's not perpendicular. So the gradient of B to D, y2 minus y1 over x2 minus x1. So I'll just use minus 8 minus minus 3 on the top, and 11 minus minus 4 on the bottom. So you've got minus 8 plus 3 is minus 5, over 11 plus 4 is 15. That equals minus a third. So y minus b equals mx minus a. You can use either the midpoint or point B. I'm just going to use the one that's sitting right here. So I've got y plus 3 is minus a third x plus 4. So I can do 3 times y plus 3 is minus 1 times x plus 4. Taking the denominator away, 3y plus 9 is minus x minus 4. Or 3y plus x equals minus 13. And we're done there, and that's fine. So for the altitude, we are going to need to find the gradient between C and B. So just a reminder, C equals minus 3,6. And B was equal to 11 minus 8. So our gradient is equal to minus 8 minus 6 over 11 minus 3. That's minus 8 minus 14 over 14, which is minus 1. So the gradient of our perpendicular is equal to 1 because m1 times m2 equals minus 1. And then we need a point. So for altitude A to E, we can use point A, minus 5, 12, minus 5, minus 12. So our point A, minus 5, minus 12. So y plus 12 equals 1, x plus 5, or y equals x. 5 take away 12 is minus 7. And we get our second equation. C, find the coordinates of intersection. So we've got two equations, solve them simultaneously. So our first equation was 3y plus x is equal to minus 13, and our second equation was y equals x minus 7. So making them both look the same, I'll have 3y plus x equals minus 13, and I'll have y minus x equals minus 7. We can add them together to get 4y minus 13 plus 7. Minus 13 minus 7, minus 20. So y is equal to minus 5. And now to get our x, y equals x minus 7, remember. So minus 5 equals x minus 7. So x equals minus 5 plus 7, 2. So our point of intersection is 2 minus 5. And we're done there. SQA Higher Maths 2022, Paper 2, Question 1. Find the equation of altitude for C, the median for B, and the point of intersection. So we've got minus 1 down here. We've got 2 minus 4. And we've got 7, 3. Okay, so first of all, altitude through C. So starting at C, cutting this one at right angles. We need the gradient of A to B. So that's minus 4 minus 1 over 2 minus 1. Minus 4 add 1 is minus 3 over 3, which is minus 1. So the gradient of our perpendicular is equal to 1 because m1 times m2 equals minus 1. So we've got y minus 3 is 1x minus 7. Or y equals x minus 7 add 3 is minus 4. So we've got our equation for our altitude. Part B, find the equation of the median. So median through B means we need the midpoint of A to C. So let's call the midpoint M. We've got minus 1 plus 7 over 2. And you've got minus 1 add 3 over 2. 7 minus 1 is 6, divided by 2 is 3. 3 minus 1 is 2, divided by 2 is 1. So we get 3, 1. So we need the gradient. So using our points 3, 1, and the other point we're going to need to use for our median is point B, 2 minus 4. So we've got minus 4 take away 1 over 2 take away 3. That's minus 5 over minus 1, which is 5. Y minus 1 equals 5x minus 3. So y equals 5x minus 15, add 1 is minus 14. We've now got two equations. Chances are we're going to solve them simultaneously. Find the coordinates of the point of intersection of the altitude and the median. So we've got two equations, y equals x minus 4, and we've got y equals 5x minus 14. So we can say that 5x minus 14 equals x minus 4. That gives us 4x on this side equals minus 4 plus 14 is 10. X is 10 over 4, which is 5 over 2, or you can write 2.5. We know that y equals x minus 4, so that means y equals 2.5 minus 4, which is equal to minus 1.5, or if you prefer, minus 3 over 2. So the point of intersection is 2.5 and minus 1.5. This week on Maths Today, we've been doing the whole of straight line for the SQA Higher Maths 2023 exams. Hopefully you found that useful and helpful. Give it a like and a thumbs up. Take care, stay safe, and goodbye.